welcome. Mathematics is full of wonderful, curious things that are also puzzling. Let's have a look at some of them. Let's start by calling a to be any number that is not equal to 0. And let's call b a as well. In other words, let a equal b, where both are not equal to 0. We can multiply both sides of the equation by b because b is not equal to 0. So we have ab equals b squared. Now subtract a squared from both sides. We keep the equation balanced by doing that. We can factorize in turn. On the left, we can take out a factor of a, and on the right, we can factorize by using the difference of two squares method. Notice now that the two brackets, b minus a on the left and on the right, are exactly the same, and we can therefore cancel them. And what are we left with? A equals b plus a. Now as our final step, subtract a from both sides, and we are left with 0 on the left and b on the right. In other words, we have b equals 0. But there seems to be something wrong there because we started by saying a equals b. So what's happened? Think about that while we go on to the next one. Let's start by calling x to be the decimal number shown. It's an infinite recurring decimal. In other words, it goes on forever, and all the digits after the decimal point are 9. We can split up that decimal and write it as a sequence, an infinite sequence, as you can see. In fact, it is a geometric sequence, and there is a formula that we can use to sum those terms of an infinite geometric sequence. Here it is. It's a over 1 minus r, where a is the first term and r is the common ratio 0.1. In other words, what we multiply each term by to get the next term. When we make the substitution, we end up, lo and behold, as the infinite sum to be x equals 1. But again, there seems to be a contradiction here because we started by saying x is 0.999 recurring, and now we found that it is exactly equal to 1. What's happened? Let's move on to the third one. Here we have a large triangle consisting of 4 colored shapes. The area of the large triangle, using the formula for a triangle, a half times the base, 13 times the height, 5, 32.5 square units. Now we can rearrange those pieces to form another triangle, and the other triangle is exactly the same size as the original, but do you notice something? There seems to be a missing square. 1 square centimetre has disappeared, even though every other piece remains the same as the original. And have a look at it carefully. So the area of the second shape is 31.5 square units. Where has the missing square centimetre gone? Here's a similar idea, but this time we start with a square shape, an 8 by 8. The area, of course, is 64 square units, and the 4 subdivided shapes we can rearrange to form a large rectangle. But notice the area of the rectangle is 13 times 5, which is 65. The original square has area 64, and the area of the larger rectangle after rearrangement is 65. Where has the missing square centimetre gone? Truly baffling. If you want to find the solutions to these, please visit www.ematheme.com. Until next time, bye-bye.